Hello, I'm Michael Nelson, and I'm here to talk to you about some of the work we're doing in our Web Science and Digital Libraries group. We're going to talk about a lot of projects from a lot of different people. Specifically talking about different ways to assess the quality of web archives. The problem is, right now, we're still in this phase of, hooray, it's in the web archive whenever something shows up. And what we should be asking is, how well did we archive it? So the example we're all familiar now with the Ukrainian separatists, they said, hey, we shot down a plane, and then later, oops, we didn't really do it, and we were just happy that, yay, we have it archived. You click on one of the videos, however, and it just sits here and hangs, right? So we have the page archived, but maybe not all the stuff archived that we'd like. So 3 ways that we're assessing quality of a web archive. There are many methods to do this, but the 3 that we're looking at, we want to determine the importance of what's missing. So we know most pages in the web archives don't have all their stuff, but not all of the things are created equal. The second thing we want to do is detect temporal violations, right? So if it's not missing and we include it, hooray, we have an image, but it's actually not the image that ever appeared with that original page. And the third thing is we've created a benchmark for evaluating how well the tools can handle all of the nasty problems with JavaScript and so forth that cause these violations in the first place. All right, so the first thing, we have a paper coming out in JCDL 2014 about not all mementos are created equal. So this is XKCD. I think I'm the first person to use XKCD today, so that's good. Now, on the left-hand side, we have the live web version of it. And this is kind of interesting because when this was rendered, and maybe it was a transient error, it was missing a handful of resources. So the M value is just the percentage that's missing. So it's missing 17%. But using our weights, and I haven't explained how we got them yet, using our weights we figured out it's actually really low. There's a low amount of damage. Essentially, what it's missing wasn't really important. In fact, you probably don't even notice that it's missing. In the middle, we synthetically took away the main image, the main cartoon. Now, intuitively, if you don't have the main cartoon, there's a lot of damage to XKCD, right? So the percentage missing is 24%, but we said, well, it's 41% damaged, right? And then on the third panel, what we did, we left the main cartoon, took away the logo at the top and the little navigation bar. The percentage missing goes up to 29%. It's still kind of damaged without the navigation bar, but the damage has gone down. So this is kind of the thing that we're trying to do, is you don't just say, well, you're missing 7 out of 100 JPEGs, so you're 93% there. We're trying to come up with weights to figure out. So for images, that's easy. Image tags and embed tags for multimedia, they often leave hints about size and centrality, where they should be placed. Turns out it's really hard for things like CSS, and CSS is often missing in web archives. So what we did is, if CSS is missing, we divide the page into these vertical thirds, and on the left-hand side, what you see is what a normal page should look like as far as the distribution of background color. So basically, each of these thirds has roughly the same percentage of background color. If you take the CSS away, on the right-hand side, you see all the content shifts to the left. And modern web pages typically aren't designed to look like this. So sometimes CSS is missing, and it's not a big deal, but if it's missing and you get something ugly like on the right-hand side, which we can algorithmically determine, we say, okay, that was probably important. That was the CSS that's really going to screw up the page. And one of the reasons talking about CSS is you're probably thinking, we thought this originally, well, screw it, it's just CSS, right? All the content's there, it's just, maybe it's arranged ugly. Turns out when you show it to real users, if the CSS is missing, they think, oh, that page is really screwed up. You've done a terrible job. And what we did is we ran a Mechanical Turk experiment. And first thing we did is showed them an undamaged page and a damaged page and made sure they could tell the difference. And most of the time they could, so that was good. And then we showed them 2 differently damaged pages of the same thing and basically got them to come up with which one they thought was more damaged. And then we essentially adjusted our weights to match so that we agree with the Turkers more often than just the straight up percentage missing, right? Because not everything is created equal. So this is sort of a screenshot of what that looks like. So some good news. This is from the Internet Archive, going left to right through time. The The blue dots are the percentage missing. You see they're holding steady, maybe even increasing. So over time, they're missing more stuff. But the red dots are slowly going down. So the stuff that we're missing is increasingly less important. So the pages are actually less damaged than they were in the past. So that's one. The second one is looking for these temporal violations. So this is an example that we like. This is a Weather Underground page for someplace in Iowa. And we see that whatever day that was, there's a light drizzle. All right, let's take a look at some of these images. So whatever date that was, 2004, 1209, the logo on the left-hand side, minus 15 hours. One of the logos is missing. Some of these thumbnails are 9 hours in the future, right? So we already have this temporal spread. The problem is we have this radar image that's 9 months in the future. And if you look, the radar image shows a clear sky, but the forecast is saying cloudy and drizzle and so forth. So it's really clear, if you look at it, that this radar image does not match the forecast. So this page never existed. You pull this back from the web archive and you get something that never existed. So how does this happen? So we have a single HTML file, and say it includes a single JPEG. And we have a timeline, and we have these changes along the way. So the correct rendering is, if I looked at the HTML file, it should pull the left-hand JPEG, the one most close to it. But we know that archives miss updates, so pretend that the correct JPEG is missing. And we go to render that page. Well, what we typically do in archives is choose the one that's closest in time. So in this case, we get one that's in the future. That's wrong, right? That combination never existed. Okay, well, don't choose the one in the future. Why would you choose one in the future, right? So choose one that's older. Well, in this case, we choose the one that's older, but that combination is wrong too. That never existed either. So what we can do is we can look for a bracket. We can build a bracket with HTTP metadata or do content comparison. But in this case, we're never going to get the right answer, right? Because the correct one is missing. So no matter how we solve that problem, we can't get the right version. So the summary graph for this project, the really interesting part is 5% of the pages that we render from the Internet Archive, we can prove to contain temporal violations, right? They absolutely did not exist in the form that we're showing them. Now, think about using pages from the Internet Archive in your legal proceedings and so forth. Think about this fact and go to sleep at night. All right. The last thing, so some good news, and this is done by Matt Kelly. You can talk to him afterwards. Coming up with benchmarks, and it's based on the ACID test. So browsers back in the day trying to, they all implemented things directly. We had the ACID test. This is what Chrome does on the ACID test. It gets 100 out of 100. Most modern browsers do that. That's a good score. That's what it should look like. We ran a bunch of tools and various archives. We ran them against ACID test, and I see my placement is messed up, but they don't quite do as well. Archive today gets a perfect score. All right, so that's for the ACID test. That's for browser functionality. Matt came up with something called the archival ACID test. So he set up a different set of tests for testing some of it's JavaScript, but some of it's HTML5 features and so forth. Run it against Chrome, everything works. Obviously, all the modern features work in Chrome. When we tested against the archives, we see that basically nobody gets a perfect score, right? So we know right away that one of the reasons why we're getting all these violations and so forth is none of the browsers, even if they have the content, they can't successfully replay all of the content that we have. So another side effect is one of the things that we test, Mummify it. It died recently, so archives don't last forever. They die at a pretty good clip as well. All right, so the future of web archiving, I'm going to claim, is increasing quantitative analysis, right? We need to stop celebrating the fact that it got archived and really ask the hard questions about how well did we archive. We need to move from, well, we're missing this many JPEGs and this many style sheets, and try and figure out if what we're missing is important. Now, obviously, if you're missing, it's hard to figure out what's important, but that's what we're working on. Even if it is present, it doesn't mean that it belongs there, right? So temporal violations are definitely a problem, and we had different categories of possibly violative and so forth. We're not even presenting that. 5% of the things we know are not correct. And then finally, to improve the quality of the archives, we actually need this benchmark, and Matt's work represents a real contribution in this so that we can compare and hopefully get better tools and help hit this off in the future. Thank you.
We now have an opportunity to answer any questions you might have or respond to comments. Yes, right here in the front.
I think this analysis of the quality of archive versions is really interesting.
So I just said some nice words. This analysis of quality of damage on an archive, I think, is very interesting. But I wonder what kind of assumptions lie under this idea that you can understand what is the important thing that is missing on a website. So there is this, and how it can be then put into a computer software. So of course this style sheet thing will work for certain kind of web pages, but for what kind of web pages will it work? Because you're kind of measuring against a certain level of utility, as I understand, of a web page. But there are web pages like, I don't know, the Nyan Cat that will be difficult to measure the utility for or something.
Right, so there will definitely be pages for which the automated analysis are not applicable, right? And as you get into more sort of art and so forth, that'll get harder. What we're trying to do, first we came up with a set of weights, and we said, well, this probably represents what we think is a damaged web page. And then we checked it with what the Mechanical Turkers thought was a damaged web page. And then we thought, well, wow, how are we going to educate all these people about what a really damaged web page looks like? And then we decided, I think we're going in the wrong direction, right? We had to sort of put aside our notion of what was damaged and useful. And you saw some of the text in there, right? And so it was really about use for a purpose, right? And we said, we saved these 2 pages. Which one do you think is more useful? And basically we're learning from what other people in mass think about the quality of the 2 pages. So at some point we sort of threw up our hands and said, you know, to the extent that we can trust Mechanical Turkers, right? Our idea of damage is trying to reflect what other people think. Because, I mean, we're all sitting here saying we want people to use the web archive, so we have to sort of put aside our own little notions about, you know, what's damaged and not. But I agree that we'll break down on these weird corner cases and so forth. But from our point, we did this when we did a large-scale analysis, right? So you've got 1 million pages, you've got 1 million pages. Let's talk about mean damage. Let's talk about distribution of damage. And I'm sure you can pull out anecdotes where it fails, but if it works for 80, 90%, then that's great.
Michael, have you considered using adaptive rather than fixed weights by looking at, say, what are the important resource components of certain categories of web pages that may differ?
So we've thought about that, but we haven't done that. That would be a really good point, right? If you know this is a news web page or something like that, and if the video is missing, so there's huge penalty if the video is missing, right? Because if you say you have a YouTube page and the video is not there, then you know. But some news pages, the text matches the video, so if the video is not there, maybe you haven't lost everything, you know. But that's a good point. We haven't gone that far.
Okay, Trevor.
So 2 quick questions, one for Michael, one for Jimmy. So Michael, is the idea that these would be useful in QA in the actual collecting process, so that you're comparing, say, the live, what it looks like at the moment you would be trying to collect it with what you've actually collected, or is the case sort of distinct from that? And then I'll ask both questions and you guys can go for it. And then my question for you is, where you see this sort of path forward, are the interfaces that you're seeing and sort of topic modeling things that you'd imagine, say, libraries throwing on top of collections as part of the actual interface they provide, so alongside, say, Wayback or something like that? Or do you see them, I'm just curious about where you see there's just, ultimately, it sounds like there's a whole ton of different potential points of entry that are coming out of this, and is this something that institutions are running? Is this stuff that scholars are running? Is it, I'm just interested in the sort of use case trajectories. So those are my two questions.
All right, so my question is about what are you comparing it against, right? So our viewpoint is, if you're archiving something today, you could certainly make an assessment, and if things are going badly, then maybe you could change and recrawl or target, like make sure you get CSS and things will greatly improve, right? On the other hand, if you want to evaluate your 2005 archives, well, there's nothing you can do about it, right? It will never be 2005 again. So, but on the other hand, if you're going to use that as the basis for your further research, right, then maybe you should have a quantitative notion about, as far as the entire archive, what was the quality of that archive, and then say, well, the pages had this distribution of damage scores or something like that. They were missing a lot of JPEGs, but it turns out they weren't important, right? The main stuff was there, or vice versa, right? And that seems like a necessary baseline.
So the question of the role of these tools like topic modeling and network analysis, I think it really needs to be driven from users who have substantive questions. And so this particular use case, we're collaborating with political scientists that actually do want to know the evolution of doctrine, the evolution of ties, things like that. And so I think asking, is this interface useful for X, Y, and Z is sort of not a well-formed question in the abstract, right? And so sure, I mean, I can think of this as an additional way of exploring archives that can be put on top of libraries or the I or whatever, but you have to consider what are the use cases, and I think that's one of the questions that sort of I'm grappling with right now. So for a long time, my focus was on building infrastructure and building the scalable platform that could process terabytes and hopefully petabytes of data. But then they really need to move together in sync, right? The tools need to be driven by the needs, and the needs inform the development of the tools in this sort of cyclic pattern.
So I'm here. I have a question. I was really struck by the hammer, Jimmy. Full disclosure, I'm in the faculty at the high school with Jimmy, so I guess I can ask him this question.
He's not playing, by the way. So.
As long as you don't use that hammer, Jimmy. But so I think that well, the reality is that if you probably survey institutions with web archives, probably the heavy users would be, what, 5 people, 10, with heavy technical background. But I do think that the future ought to be more like everybody can use the collection, just like any collection in an archive repository we have now. Right? So I just think that, don't you think that we should do more user-based evaluation where the assumption of the user is not a highly technical person? And how do we get to that?
Yes, absolutely. I don't have an answer to that, which is why I asked you, Ricky. So I think this could be a rhetorical question that you answer yourself. But yes, I mean, yes, for this particular project, the focus of my collaboration has been on knowledgeable people that have these deep substantive questions. I think it's a little bit more challenging to try to how do you get access to the typical casual user of a web archive? I don't know. So perhaps something like log analysis on the archives that are already present might be a good start. But then it's limited by the available capabilities, right? And so this is once again getting into the chicken and egg problem.
So this was a fantastic presentation, by the way. I'm back here. Hi. Really inspiring. I guess I have sort of a comment. You presented a hammer. As someone who uses web archives and also collects web archives, Something that I'm constantly running up against is the question of wanting to access them by identity and not by URL. Stephen kind of brushed across this, but it's something that I think archivists, and I'm a records manager also, we think about a lot, is the tracking identities across time, past name changes, past even reorganizations, and that sort of stuff. And so wanting to be able to look at a web presence as it existed maybe on a different namespace in a different time. And as librarians and archivists, we look at that and say that's a metadata problem. But I think that perhaps the hammer that you're presenting might be that it's actually a computation problem, and that there might be ways to compare and come up with best possible matches and those sort of things. And that would be, I think, my 2 cents, something really useful to the typical user.
Yeah. Yes, absolutely. That actually is a research question from the information retrieval literature. The specific name is entity finding. And progress has been made about it. The problem is this, right? What you really care about is an entity in the world, and you want to find a canonical homepage, whatever the canonical homepage might be. It might be everything from a Wikipedia page to a Twitter landing page to a LinkedIn profile, whatever. But being able to think about the entity as the abstract thing that you're archiving as opposed to individual pages. And I think here is an opportunity for archivists and computer scientists and others to sort of work together. Absolutely.
I think in terms of access to web archiving, I think there is a, in comparison, if we think that we think about the live web and the purpose of using this, there's a business-driven reason for use web, live web right now. But when we archive this material into our web archives, so we're not quite clear at this point, and who, I think someone already mentioned, who will be using them, for what reason. We're trying to kind of understand that the future use for that. That's kind of totally different from the current web community.